This lesson is going to be on logarithmic differentiation. So the first question I want to look at is, what is the derivative with respect to x of 7 to the x? Now I'm just going to say right now, it is not x times 7 to the x minus 1. The power rule does not extend to exponential functions, so be careful of that. So let's show you what it really is. We're going to say y equals 7 to the x, and we're going to use logs to help us proceed. So we're going to take the natural log of both sides of the equation. Natural log here, natural log there. So natural log y equals natural log 7 to the x. And then we know we can pull the exponent down in front to say natural log y is x times the natural log of 7. At this point, we're going to take the derivative with respect to x of both sides. The derivative with respect to x of the left side. The derivative with respect to x of the right side. The derivative with respect to x of natural log y equals the derivative with respect to x of x times natural log 7. So what do we get? What is the derivative of log of something? Let's remind ourselves of the basic ideas, right? The derivative with respect to x of natural log x is 1 over x. So the derivative with respect to x of natural log something is 1 over the something times the derivative of the something. So we want the derivative of with respect to x of natural log of y. The derivative with respect to x of natural log of y would be 1 over y times the derivative with respect to x of y. So the derivative with respect to x of log y would be 1 over y. The derivative with respect to x of y is dy dx. So that's my left side here. My left side is 1 over y dy dx. Now, what do we do on the right side? Now, I just need you to recognize that the natural log of 7 is a constant. It's a number that happens to be natural log 7, about 1.946. So we're going to pull that out in front of the derivative operator. So it's going to be natural log of 7 as a constant times the derivative with respect to x of x, which of course is just 1. The slope of x is 1, so it's 1 over y dy dx equals natural log 7 times 1. So where does that put me then? Then again, 1 over y dy dx equals natural log 7, fine. But then I've got to solve for dy dx. So what does dy dx equal? Multiplying both sides by y, dy dx is y times natural log 7. But what is y? Remember what y is? Well, up here we defined y to be 7 to the x. So dy dx, the derivative of 7 to the x, is 7 to the x times log 7. Now, let's check that if we can. I'd like to go to the graphing calculator and actually check to see if that's what we get. So my function here is 7 to the x power. And I'm going to have the calculator tell me what its derivative is. So number 8, numerical derivative with respect to x of y1 at every point x. So what's in red will be the derivative function. So I can do a zoom standard maybe on that one. And there's the graph. And then what I think it is, I think it's 7 to the x times natural log 7. So the black graph, 7 to the x times natural log 7. We hope graphs directly on top of the red graph, which is what we believe the derivative to be. And sure enough, the black graph goes directly on top of the black graph. So that makes us feel pretty good. So that's our first example. The derivative of 7 to the x is 7 to the x log 7. But let's remind ourselves of the process. What did we do? I wanted to get the derivative of 7 to the x. That was my goal. I guess I never stated that. Find the derivative with respect to x of 7 to the x. Then I had to write y equals 7 to the x, take the log of both sides, do the algebra, pulling the exponent down and such, and then take the derivative of both sides with an implicit derivative, right? The derivative of natural log y 1 over y dy dx. Then I solve for dy dx by plugging the y back in. So you're going to see that that's our strategy we're going to use for many of these problems. Let's do another problem that's not quite the same. So our goal here is to find the derivative of x to the x. Find the derivative with respect to x of x to the x. How are we going to do that? Well, we're going to define y equal x to the x, and our goal is to find dy dx. Okay, y is x to the x. We're going to take and hit both sides of the natural log. So natural log y equals natural log x to the x. And then I can pull this exponent down. So I get natural log of y equals x times the natural log of x. And then our next move is take the derivative with respect to x at both sides. The derivative with respect to x of the natural log of y is going to equal the derivative with respect to x of x times the natural log of x. As we've seen earlier, the derivative of with respect to x of natural log y, right? The derivative with respect to x of natural log something is 1 over the something times the derivative with respect to x of the something. So the derivative with respect to x of natural log y is 1 over y times the derivative with respect to x of y. So we get 1 over y dy dx. We get that for this piece. Now over here, I want to get the derivative with respect to x of x times natural log of x. That's going to require us to use the product rule. So we'll say u is x, and we'll say v is natural log x. U prime, the derivative of x is 1, v prime, the derivative of natural log x is 1 over x. And we know that uv prime is u prime v plus uv prime. U prime v 1 times natural log x plus u x times 1 over x. So 1 times natural log x is just natural log x plus x times 1 over x is just 1. So the right-hand side here becomes natural log x plus 1. And we're almost finished. I want to solve for dy dx, so I've got to multiply both sides by y. So multiplying both sides by y gives us dy dx equals y times natural log x plus 1. But what was y? What was y? What do we say y was? Y was x to the x power. So we finish this with dy dx equals x to the x times the natural log of x plus 1. Certainly not x times x to the x minus 1. Power rule doesn't extend to that kind of a function. So let's check that on the graphing calculator. So we will put in the original function, which is x to the x. And try to delete this craziness. And notice I have y2 already here, which is the derivative of y1, so that's going to be graphed in red. So I'll turn off the blue function, which is x to the x. And I will graph the red function, which is its derivative, and maybe I'll do zoom decimal on this one. Kind of a crazy looking function. And let's graph what we think our answer is. We thought it was x to the x times natural log x plus 1. So that was in red. We will do in blue now x to the x times natural log x plus 1. Be careful with order of operations. Gets a little tricky. So does the black graph on top of the red graph? We hope so. And sure enough, it does. So that's an indication that it's correct. So this is a really nice tool. It enables us to solve a lot of problems without memorizing different